Hello, and welcome to Graphing Exponential Functions. All right, so the fact is the exponential functions have a horizontal asymptote. And the horizontal asymptote is just a horizontal line that the graph gets increasingly close to as the values of x get increasingly large, whether they're positive or negative. So like towards positive infinity, towards negative infinity, at the ends of the graph, exponential functions will kind of settle in on a specific number. Now, for an exponential function given by f of x equals a times b to the x, with a not 0, b greater than 0 but not equal to 1, we have four possible graphs. So if a is greater than 0 and b is between 0 and 1, for example, maybe a is bigger than, so it's 2 1/3 to the x. Right, something like that. My a value is positive. My b value is a proper fraction between 0 and 1. Our graph will be above the x-axis and decreasing. So our graph will look something like that. All right. Whereas if a is positive and b is greater than 1, the graph is increasing and above the x-axis. So maybe we'll have, let's plan this out ahead of time, shall we? Maybe y equals 2 times 3 to the x. This graph will be generally increasing and above the x-axis. This is going to come in. We have a horizontal asymptote here at x equals 0. Notice the graph is increasing as we look at it from left to right. I don't like either one of those, so I'm going to draw it again. There we go. A little more asymptotic there. If a is less than 0 and b is between 0 and 1, the graph is increasing and below the x-axis. So I'm going to do both increasing in blue. Let's go with minus 3 1/2 to the x. The graph will be increasing and it will be underneath. Notice that the graphs I have over here on the right, all it is just a reflection. If I were to graph these, they might look like a mirror image of each other, really. I use different numbers, so ignoring numbers, of course. If a is less than 0, so we have a negative a, and we have a b that's bigger than 1, the graph will be decreasing and below the axis. So a is less than 0, so let's use a negative 3. B is bigger than 1, so let's make it 2. Then our graph will be decreasing and below the x-axis. So these are the only four graphs. So we could shift them right and left. We could shift them up and down. We could stretch them. We could shrink them. We could do all those things. But essentially, we have only these four graphs. And for that reason, I'm going to show you four examples. Let's sketch the graph of the following functions by hand. So we don't even need our calculator. Explain what the values of a and b tell you about this graph. Also find the domain and range of each function along with the equation of the horizontal asymptote. Wow, that's a lot. So let's sketch it first. First of all, a equals 4 and b equals 5. So positive and bigger than 1. I know this is what my graph should look like. But what really happens here is, check this out. I'm going to use an x value of 0. When x is 0, I'll have 4 times 5 to the 0 power. Now, we know that anything other than 0 raised to the 0 power will be 1. So this will be 4 times 1, which is 4. Notice that the y-intercept is the point 0, a. That's how the a hooks us up in finding our values. But you see what the base multiplier does. Suppose I go one value after that. So if after an x value of 0, I increase my x by 1. The base multiplier says, hey, I'm going to multiply by 5. This will be 20. And I can check it over here. 4 times, in parentheses, 5 to the first power, 20. And I bet if I did this again, and I made this the second power, all right, if I increase by x by 1 more, I'm going to take that 20, I'm going to multiply it by 5. This is going to be 100. And so we don't actually have to evaluate. If we use this whole idea of the base multiplier, we're going to multiply by 5 each time x takes one step forward. Similarly, we're going to divide by 5 for each step backwards from our starting. All right, so I have all of the x and y values that I'll need. In graphing these, well, certainly not enough room to do that problem on this page. So while we're graphing these, since it's positive and positive, I know it's going to be all above the x-axis. We have -1, -2, 1, 2. I'm going to use a scale of 5 on my y's though. 5, 10, 15, 20. I know when x is 0, my y value is 4. I know when x is 1, my y value is 20. When x is 2, I'm off the charts over here at 100. At -1, I'm at 4/5. 4/5 is pretty low here. Close enough is good enough. Remember, we're just making a sketch of the graph, so we just want to show the basic shape of this graph. My domain for every exponential function will be the set of real numbers. My range will be always referring to 0, because it's, in this case, it's only positive values. And this x-axis, that is the horizontal asymptote that I mentioned earlier. And in this case, y equals 0 is the horizontal asymptote. Horizontal lines always have a y equals a number, and in this case, it's 0. All right, so let's see. Sketch by hand. What do A and B tell us? A tells us where to start. B tells us how to get the next value as x changes by 1. Find the domain and range and the equation of the horizontal asymptote. Let's try another one. So we find that A is 300 and B is 3/4, which tells me if I wanted to write down some values, I'm going to start with an x value of 0. My y value will be 300. It's exactly what A means. Now to move forward, I will multiply by 3/4. I'm slightly distracted. I have one of my dogs snoring in the background, and it's so cute when she snores. We get 225. And if I go backwards from there, I'll divide by 3/4. So I'm going to take my 100. I'm going to take the same thing, but I'm going to change that multiply to a divide by 3/4. I'll get 400. So once you have your A value, you can find your y-intercept, plot your y-intercept, and x steps up by 1. We multiply that y value by b to get our new y value. And when we step backwards, we divide by that b value. So my graph looks like this. Let's see. At -1, let's go 100, 200, 300, 400. -1, 400. 0 is 300. 1 is 225. And I've totally ran off the paper here. But if I were to able to keep this going. Wow, how horrible was that line? Okay, let's try that again. It would eventually get super close to my asymptote here. And I ran off the paper, but you get the idea. So it's still going to decrease. It just, because this 3/4 is so tiny and we're starting up here at 300, it takes forever to decrease. And we can see this In a graph on our calculator, no, 3/4 to the x power when we graph that, nothing shows because my window is so small. So let's fix our window. We know we need to go up in the y direction, y maximum of 400. Here, I don't have very many x values, so let's take x out to 100. I don't know, let's see what happens here. And you can see that that was just excessive. So let's take our x value back down to 20 or something like that. Here we go. And magically, the graph appeared because I had to pause the recording real quick. And we see this same graph. If we take a bigger version of it, we see that it does become asymptotic, the action of being an asymptote. We have our domain of all real numbers. We can put in any x value we want. It's all good. Our range will be 0 to infinity because this one's above the graph. And y equals 0 is still our horizontal asymptote, but it's now the horizontal asymptote on the right, whereas our previous example had a horizontal asymptote on the left. All right. For f of x equals -7 times 3 to the x, our a value is -7, our b value is 3, which tells us if x is 0, my a value is -7. If x goes up by 1, my b value multiplies by 3. If x goes back by 1, I'll divide by 3. So that's -7/3. And I'll use this every time. If I want to keep going forward, I'll multiply by 3, multiply by 3. So if, as x goes up by 1, y gets multiplied by 3. It looks like these y values are all negative, which we were expecting. A negative a and a b value bigger than 1. Let's see what we have. We have, wow. Let's take 5, 10, 15, 20, 25. Okay, so if we count by 5 on the y's, -7/3, that's pretty close up in here. We'll make it up there. 0, -7, if that's 5, 6, 7. And 1, -21. We find we have this graph. Do your best to make it a nice sloping graph. Sometimes it gets a little crazy, but it's not line segments. Try to make it a nice smooth curve. And as always, you can check it on your graphing utility. The domain from -infinity to infinity. The range, notice how it's all negative values up to 0. So now it's -infinity, stops at 0. The parentheses, because we never actually touch 0. There's no x value I could put in that will make the output 0. And again, what is our horizontal asymptote? It's y equals 0. Only on the left side. The right-hand side doesn't settle on a number, but the left side, if x gets small enough, we'll settle in on a number. And our last example has an a value of -100, a b value of 1/4. So my x and y values. At 0, I'll have -100. If I move forward, I'm going to multiply by 1/4. Right? My base multiplier b is 1/4. 1/4 of that is -25. If I go backwards, I'm dividing by 1/4, which is multiplication by 4. And I could keep going back, or I could keep going forward. And so I could keep doing this. It's not just the values right near 0. It's all of them have that same pattern. So when I focus on what it is I need to do here, we're going to graph. Notice all my y values are negative. So I don't even bother with kind of the top piece of my graph here. Let's roll by hundreds. 1, 2, 3, 4, negative 500. I'm going to keep these values nice and kind of straightforward. I have a 1, 2, negative 1, negative 2. Negative 2, 1600 is way too hard for me to find. It's like down here somewhere. I don't know. Negative 1, negative 400 is here. 0, negative 100. 1, negative 25. And we find, I'm not going to use that one. We find that we once again have a horizontal asymptote. We have a domain of all real numbers. With all 4 graphs, my domain was all real numbers. We have a range. Notice since this graph is below the x-axis and increasing, but it still never crosses that x-axis, it will be negative infinity to 0, parentheses, because we'd never touch this horizontal asymptote. You can touch horizontal asymptotes, but we don't here. And the horizontal asymptote is always the equation of a line, and this line is y equals 0. That's it for graphing exponentials using A and B. What do they mean? Domain and range. Thanks for listening.